Luyten star B already has intelligent wildlife. You are standing on its vibrant alien surface, not gazing at a distant speck, but feeling the ground beneath you, solid and substantial. A super-Earth nearly 3 times the mass of our own world. The gravity pulls a little heavier here, an omnipresent reminder of its substantial nature. The sky above isn't a familiar blue. It's a perpetual twilight, painted in deep reds and oranges from its dim, calm M-type dwarf star, Luyten star, a sun that appears 15 times larger than Earth's sun, yet much less blinding. This isn't a theoretical thought experiment. This is your immediate reality, a world teeming with a civilization that developed under a crimson sun, 12 light-years from Earth. The intelligent life on Luyten star B isn't humanoid, nor are they necessarily carbon-based in the exact way we understand. Their very biology, their culture, their technology has been forged by the unique conditions of this world. Imagine sprawling cities, not reaching for the sky in vertical ambition, but perhaps burrowing deep or spread wide and low, embracing the greater surface gravity. This planet, sometimes called GJ273b, receives just 6% more starlight than Earth, making its equilibrium temperature remarkably similar to ours, around 259 Kelvin, or minus 14 degrees Celsius, which with an Earth-like atmosphere could mean a balmy 19 degrees Celsius average surface temperature. This suggests vast oceans, perhaps even an archipelago planet of shallow seas dotted with island chains, ideal for diverse life to flourish, driven by the star's infrared-rich light. Their intelligence likely evolved at an accelerated pace, benefiting from a planet that avoided the fierce stellar flares common to many red dwarfs. Luyten star is unusually quiet for an M-dwarf, with a long rotation period of around 118 days, which drastically reduces the powerful stellar outbursts that could strip away an atmosphere and sterilize a world. This prolonged period of relative calm allowed for a stable environment, a continuous crucible for evolution over billions of years. Think of the consistent, steady pressure for adaptation this long-term stability would provide, creating a relentless yet sustained evolutionary drive towards complexity and eventually sentience. Their days are long, matching their orbital period of 18.65 Earth days, a significant stretch of continuous light or darkness if they are tidally locked. But if its slightly elliptical orbit prevented perfect tidal locking, as some theories suggest, they might experience a spin-orbit resonance, like Mercury, where a day could be shorter than their year, leading to fascinating and complex patterns of light and shadow, wind and weather. This could have shaped their physiology, their sensory perception, their architecture, even their temporal understanding. How would a civilization perceive time when their day stretches for weeks of our Earth time? Their cycles of work, rest, and creation would be profoundly different, potentially leading to a vastly different societal structure and psychological makeup. The constant glow of Procyon, Luyten star's much brighter neighbor, would be a permanent fixture in their sky, shining brightly enough to be seen even during their dim daylight hours. This celestial beacon, a bright white-yellow star, would have been a constant source of wonder, perhaps even spiritual significance, influencing their myths, their navigation, and their early understanding of the cosmos. Imagine their astronomers studying Procyon long before they even conceived of their own system's geometry, its steady light a contrast to their own star's ruddy glow. Their technology, developed under these unique conditions, would be unlike anything we've conceived. With higher surface gravity, their engineering feats might focus more on strength and stability than sheer height. Perhaps their energy systems are highly efficient at harnessing the infrared spectrum, which dominates their star's output. Their material science might be advanced beyond our current capabilities, using the denser elements more readily available on a super-Earth. Consider the societal implications. A civilization that grew up with a constantly present larger sun and heavier gravity. Their art, their philosophy, Their very sense of place in the universe would be imbued with these fundamental differences. And what about communication? We on Earth have already sent messages towards Luyten star B, a binary code tutorial in science and math, along with 33 musical compositions transmitted in 2017 and 2018. If intelligent life is indeed there, those messages have now reached them. How would they interpret our crude attempts at interstellar communication? Will the mathematics be universal? Will the music resonate? Or will it be perceived as alien noise, a curious, fleeting ripple in the cosmic background radiation? If they have heard us, and if they chose to reply, their answer could be en route, potentially reaching Earth around 2042. What would that reply contain? Would it be a confirmation of understanding? A new 10 plus 10 equals 20, as some suggest, demonstrating a shared logic? Or would it be something entirely unexpected? A burst of information so profound and complex that it would take us decades, centuries even, to decipher. The very act of receiving a reply would instantly and irrevocably alter humanity's perception of its place in the universe. We would no longer be alone, a singular point of consciousness in an empty cosmos. The existence of intelligent life on Luyten star B would challenge our hard steps model of evolution. The idea that complex life requires a series of rare, improbable events. This alternative model suggests that intelligence is a natural outcome of a hospitable environment, and Luyten star B, with its relatively calm star and comfortable habitability, could be a living testament to that theory. It suggests that the emergence of complex life may be less about luck and more about planetary conditions evolving in sync with life itself. This means the universe could be teeming with intelligent species, far more than previously thought. Their history would be vast, potentially billions of years older than Earth's multicellular life, given the longevity of red dwarf stars. This means an ancient civilization, potentially having navigated countless evolutionary bottlenecks and technological advancements we can barely fathom. Their social structures, their philosophies, their understanding of existence could be profoundly mature, shaped by eons of continuous development. What societal problems would they have solved? What existential crises would they have faced and overcome? What kind of technology would they have developed over such a mature timescale?
Perhaps their technosignatures are not radio waves at all, but something far more subtle or even grander. They might be manipulating their environment on scales we can't yet detect, or their advanced understanding of physics has led to communication methods beyond our current grasp. Imagine megastructures, not necessarily Dyson spheres, but subtle alterations to their planetary environment to optimize for their star's unique light, leaving a detectable imprint in the exoplanet's atmospheric data for those who know how to look. Industrial pollutants, chlorofluorocarbons for example, or even specific rare isotopes from nuclear reactions could be telltale signs if their technology mirrored ours in some fundamental ways. The discovery of intelligent life on Luyten star B would ignite an unprecedented scientific and philosophical revolution on Earth. Every field, from biology to sociology, from physics to theology, would be forced to reevaluate its fundamental assumptions. The search for other forms of life would intensify, and our understanding of intelligence itself would broaden beyond our limited, Earth-centric view. We would begin to ask not just what if life exists elsewhere, but what kind of life, and what can it teach us? The crimson light of Luyten star B would forever change the canvas of our cosmic imagination, transforming a distant point of light into a vibrant, living world, a mirror reflecting our deepest questions about existence.